Now let's just move on further towards the next theorem, which says that the diagonals of a parallelogram bisect each other. So let us suppose if I'm just taking this parallelogram. So in this parallelogram, if I'm just taking the two diagonals, that is BD and AC, so I just have to prove that they are bisecting each other. So let us suppose if I'm just starting with the given condition over here. So what is a given condition? Given is nothing but a parallelogram ABCD, a parallelogram ABCD with AC and BD being the diagonals, intersecting being the diagonals, intersecting at the point O. So I have taken these diagonals that are intersecting each other at the particular point O. Now what we have to prove over here, let us suppose if I'm writing, we have to prove that OA is equal to OC and OB is equal to OD. We just need to prove this thing. So now let's just start the proof of this particular theorem. So I am just taking the two triangles over here. In triangle AOD and triangle BOC, I'm just taking the two triangles over here. The very first one is nothing but this one and the second one is nothing but this one. So I'm just taking these two triangles over here. So since we know that it is nothing but a parallelogram, since ABCD is a parallelogram, so as per the properties we know that the opposite sides are equal. So if the opposite sides are equal, it implies that AD is nothing but is equal to BC. So we know that this side is equal to this side. Moreover, we know that if I am just taking these angles as nothing but angle 1 and angle 2, let us suppose if I'm just taking this as angle 1, I'm taking this as angle 2, I'm taking this one as the angle 3, and furthermore I'm taking this one as the angle 4. So since we know that since AD is parallel to BC and BD being a transversal, it implies that angle 1 is equal to the angle 1 is nothing but is equal to the angle 2. Why so? Because they are forming up a pair of the alternate interior angles. So they are alternate interior angles. Moreover, since DC is parallel to AB, and AC being a transversal, implies that angle 3 is nothing but is equal to the angle 4. Again, they are alternate interior angles. So in triangle AOD and triangle BOC, what we are getting angle 1 is equal to the angle 2, we are getting angle 3 is equal to the angle 4, and furthermore we know that AD is nothing but is equal to BC. Since it is already given to us and we have proved this thing from the equation number 1. Let us suppose if I'm taking it as 1, from 2, we are getting this thing. So hence from these three things, what we are getting, that the triangle AOD is actually congruent to the triangle BOC by ASA congruence rule. The two triangles are congruent, and if the two triangles are congruent to each other, it implies that OA is equal to OC and OB is equal to OD by CPCT. So hence this is the thing that we have to prove over here. Hence proved that the diagonals bisect each other. Each other in a parallelogram. So this is nothing but the proof of this particular theorem.